Hello friends, in today's video we are going to learn about decision tree classifiers. We are going to use the iris dataset for our demonstration. So if I run this first code cell, we are actually taking only the last two features of the iris dataset, that is the petal length and the petal width. So this is how the numbers look: 1.4, 0.2, that is 1.4 is the petal length, 0.2 is the petal width. The targets that we are going to predict are Setosa, versicolor and virginica. These have been label encoded, so they are 0, 1 and 2. This is the syntax of declaring the decision tree classifier object and taking the max depth equal to 2. We fit the decision tree with dot fit command, and then this code cell actually saves the representation of the tree in a dot file, and the upcoming code cell converts the dot file to a png file. So the png file looks something like this. Now if we have some new instance, for example, let's see, so maybe we have an instance which has a petal length of 2.1. It is predicted as 0, so 0 means setosa. As we can see here that it is less than 2.45, so it has gone down this path and this class is setosa. Now let us take a value that is greater than 2.45. So here it has been greater than 2.45. Now we are going to have to compare the petal width. The petal width in this case has been given as 1.76. 1.76 is greater than 1.75, so it goes down this path and predicts it as virginica. Let's see what was our prediction. So it is 2. 2 is the label encoding of virginica. Okay. So as we can see here, we have something called Guinea, and this value, as you can observe, as we go down the tree, this value keeps decreasing. It is actually the measurement of impurity of a node. So here the impurity is 0 because this node consists of instances from only the Setosa class. The value of Guinea is calculated as follows. We take 1 and then we subtract the sum of the square of the probabilities. So what is this probability? For the ith node and the kth class, the probability is mk by mi. Mk, total instances belonging to class k. Mi, total instances in the node. So let us calculate one for ourselves. Let's say, so it is 0.5 and we have 50 belonging to versicolor class, 50 belonging to virginica class. So if we do the calculation, we have 1 minus 50 by 100 whole square minus 50 by 100 whole square. When you calculate this, you'll get 1 minus half, which is equal to half, which is equal to 0.5, and that is what is written here. So we can see that this Gini value is a measurement of impurity. The lower the impurity, the more good the classification is considered, and the cost function that the decision tree algorithm uses is j of k comma tk equal to m left upon m g left. Here g is the impurity, m right upon m g right. So what is this left and right? Actually, this is the splitting that is being occurred. So while splitting in left and right, we are checking the best class K for which there is a threshold Tk that is minimizing this value. So here you can see that we are using the ratio of the number of instances that will be present in the left node divided by the total number of instances, and the number of instances that will be present in the right node upon splitting by total number of instances upon taking a certain threshold of a certain class K as weights. And this is nothing else but the impurity. So in this case it is the Gini value. So this is the expression that is used for splitting the tree. And now let us see the complexity for training. It is O of n into m into log with base 2m. This can be explained as follows. If we have a root node and we keep going down and we consider that it is a tree that is binary, as you can see, we have initially one node, two nodes, four nodes, eight nodes. And on calculating the log, we can get the value of the height, which is in this case 0, 1, then 2, and then 3. These are the respective heights. And if we take one, say, example, then we would have to traverse down one path. And since the total number of examples are m, so we have m paths. So one path would be log of m, and then we multiply it by total number of paths for all examples. And then since we are taking n features, so for each feature we are doing this, so we multiply it by n. So that is how we arrive at this expression. So thank you for watching.